ሰላም ተማሪዎች እንደምን አላችሁ? ዛሬ የአስረኛ ክፍል ሶልቪንግ ሎጋሪትሚክ ኢኩዌሽን የሚለውን ይዘን ቀርበናል ማለት ነው። ይህንንም እንግዲህ ልንሰራበት የፈለግነው ዋና ምክንያቱ ምንድነው? ብዙ ተማሪዎች በኢሜል እና በስልክ ሶልቪንግ ሎጋሪትሚክ ኢኩዌሽን የሚለው አልገባንም። በተለይ ፔጅ 177 ላይ ያለው የአስረኛ ክፍል ግልጽ አይደለምና እያንዳንዱ ዩኒቨርሲቲውን በማውጣት ሶልቭ ይደረግልን ባላችሁት መሰረት ይህንን ይዘንላችሁ ቀርበናል። for solving the problem let us consider the properties of logarithmic function. Logarithmic function a is greater than 0 and if a is different from 1 we have the following properties. The most important properties, that is log of m times n in base a for number m and n that are greater than 0. You have what? Log of what? Log of m in base a plus what? We call this log of n in base a for m and n are what? They are greater than what? 0. Similarly, log of the same property about m over n in base a is equals what? This is equal to log of m in base a minus what? Minus log of n in base a. The other property we have log of m the power of say real number r in base a is equals what? R times what? R times log of what? M in base a. The other thing we consider that log of m in base a is the power of, for instance, k, which is equals what? For any real number k 1 over k times what? Log of m in base a. The other property that we consider that log of what? Log of a the power of log of m in base a is equals what? Which is equals m, which is also equivalent to what? Log of m a the power of what? M in base a also is equals m. You have to consider these properties to solve what? The problem that we consider in case of what? Solving a logarithmic equation. To solve this logarithmic equation, we consider the following procedures. First, state the universe. State the universe means what? Determine where the domain lies. That means determine the domain. This means what? Determine the domain of what? The given logarithmic function. Its domain. The other one, collect logarithmic term on one side of the equation. That means bring logarithmic equation in one side and the equation on the other side. That means you have to collect in one side. If you have, for instance, log of x in base 2, for instance, is equal to like this 3. If we consider this one. Write the equation in the exponent form. After that, after we have this one, we'll try to express this logarithm function in the form of exponent. This means what? This means, for instance, 2 to the power of 3 is equals what? That is x. After that, solve the variable. For the variable means what? When solve this one, x is equal to what? That is 8. So we have to follow these steps or procedures to solve this. That means to solve what? Logarithmic equation. Let us consider the examples that we have. All the examples that are taken from what? Exercise 3.29. State the universe solve for x. All are lies what? On page what? On page 177. When it comes to the first, log of what? X squared minus 3x in base 2 is equals 4. First, state the what? What we state? State the universe. What the universe for this? To state this one, we say what? The x is, this must be what? Greater than 0. That means x squared minus 3x must be greater than what? 0. What does imply? This implies what? When take x common, x into x minus 3 is greater than what? This is 0. When this greater than 0, when this both are greater than 0 or what? Both are less than 0. This implies that it is true when x greater than 0 and what? X minus 3 is what? Greater than 0. Or the other option we have what? X less than, both are less than 0. That means x minus 3 also what? Less than 0. Here what? When you come to here, x greater than 0, which implies x greater than 0 or and what? And x is greater than 3. Which one is common for both? That means the common one is what? This implies x greater than 3 is what? Common. Or when you come to here, x less than 0, x is less than 0, and what? And x is what? Less than 3. Which one is common for them? That means the common one here is what? X is what? Less than what? 0. So the domain of this logarithmic equation is what? What is that? That means x less than 0 and x greater than 0. You can express using interval negative infinity to 0, union what? Union 3 to positive infinity. So the solution must lie what? On this interval. After that, we have to solve this problem. We restrict the universe or the domain. After that, we'll try to solve this one. How can I solve this? When you try to solve this one, what for? This implies what? You have to express this in the form of what? Exponent, which implies x squared minus 3x is equal to what? To the power of what? 4. Which implies x squared minus 3x. This one is equal to what? To the power 4 means what? That is 16. What for? Here is x squared minus, here is 3x minus 16 is equal to what? 0. So this is a quadratic equation. We can solve this one using what? General quadratic formula. How can we solve this one? X is equal to negative of b. Here our b is what? Negative 3. Negative of negative 3, that is 3. Plus or minus the square root of what? B square means negative 3 square. Minus what? Minus 4ac. 4, a is 1, c is what? Negative 16. Divided by what? It is divided by 2 times 1. 2a. Which is equal to what? This is 3 plus or minus the square root of what? 3 square means negative 3 square, that is 9. This is 9 plus 4 times 14, that is what? 64. Divided by what? This is divided by 2. What the value? This equals 3 plus or minus the square root of 64 plus 9 is what? That is 73. Over what? That is 2. So the value for x is what? This one. X is equal to 3 plus or minus the square root of 73 divided by what? 2. We can't take out this one since 73 is not perfect square. Perfect square. So where it lies, if we consider this one, 3 plus 73 over 2 is what? 73. If you take perfect one, 64, that is 18. 8. 3 plus 8 is what? 11 over 2. That means 11 over 2 means what? 5 point something. So the case of the positive one lies what? On this interval. When you come to the negative one, 3 minus 73, that means if you take approximately 8, the square root of this one, 8. 3 minus 8 is what? That is negative 5. Negative 5 divided by 2, negative 2.5. It also lies on this interval. So the solution for this is equal to this one. Similarly, for the case of the second one, how can I express this? For b, solution for b, again you have to determine the domain. The domain must be what? X minus 1, it must be greater than 0. What does imply? This implies what? X is greater than 1. Since log of 3 in base 2 is what? It is constant. So the domain must be x greater than 1 or which is equal to what? Which is equals 1 to positive infinity. We can express like this. After that, we will try to express this one. This is what? The sum of what? Two logarithms. If it is the sum, we can take what? As a product. This means log of what? Log of x minus 1 in base 2 plus log of what? 3 in base 2 is equals 3. Which implies what? Which implies we take the product of this one since it is sum, which is the same base log of 3 into x minus 1 in base 2 is equals what? That is 3. After this, we have to express this one what? As exponent form, which implies what? This implies 3 times x minus 1 is equals what? To the power of what? 3. To the power of 3 means what? That is what? 8. Which implies 3x minus 3 equal to 8. What the value of this? This implies 3x is equals what? When you take negative 3 to the right side, it becomes 11. what the value of x? X is equals 11 over what? That is 3. 11 over 3 is what? It is still greater than 1. So it is the value of x must be what? This is 11 over 3. So we can solve different problems using such forms. When we come to the next one, what says that log of x squared minus 121 minus what? Log of x plus 11 is equals 1. Similarly, this is the difference of what? Two logarithms. That's so we take as equation. That means a quotient of what? The logarithms, which is equals what? Log of x squared minus 121 divided by what? Divided by x plus 11 as we did before, which is equals 1. So what's the domain of this one? If you find the domain, you can find subparameter. This means what? The universe of this one is what? The universe. The first one is what? X squared minus 121 is greater than 0 and what? X plus 11 must be what? This is greater than 0. This x squared minus 121 is greater than 0 when? Since it is the square of this one, that means when x is what? Less than negative 11 or what? Or x is what? Greater than what? 11. In both cases, it is greater than 0. And last one, x plus 11 greater than 0 means what? X is greater than negative 11. After that, take the intersection of this one. X less than negative 11 and x greater than negative 11. This means this is x is less than negative 11 and what? X is greater than what? Negative 11. Or in between, what? X is greater than what? Negative 11 and what? X is greater than 11. So what's the relation between the two? X less than negative 11 and x greater than negative 11. Is there any common? No, there is no common. The common one is what? That is implicit. There is no common element for both. Or x greater than negative 11 as well as x is greater than 11. Which one is common? X greater than 11 is common for both. So when you combine all with this one, this implies what? This common one is what? X greater than 11, or we can express this as forms 11 to what? Positive infinity. We can consider this one. And there is no base here. If there is no base, that means common logarithm. The base is 10. So which implies what? X squared minus 121 over what? X plus 11 is equal to 10 to the power of what? That is 1. What does it imply? This means what? X minus 11, this one is what? Times x plus what? 11 divided by, this is x plus 11, which is equal to what? 10. Cancel this by this one. The other is what? X minus 11 is equal to what? That is 10. What is x? X is equals to 21. We take this one plus, so x, the value of x is 21. Is it on the interval? Yes. 21 is what? Between what? 11 to positive infinity. Now let us consider D similarly. It says what? X plus 6 base x is equals to what? 2. The logarithm of x plus 6 base x is equals to what? 2. In this case, what we say that x plus 6 is what? Must be greater than what? This is 0. As well as at the same time, what is that? This x must be what? X is greater than 0 and what? X is different from what? X also different from, that is 1. X greater than negative 6 and this means 0 to 1 union what? This is union what for? This is union 1 to positive infinity. This is this one. What does imply? When we take this x greater than negative 6, what for? Here is negative 6 to positive infinity and what? And 0 to 1 union, this is 1 to positive infinity. What is common for this? The common one is what? Negative 6 to positive infinity, and this one, the common one is what? This one. The common one is what? 0 to 1 union what? This is 1 to positive infinity, which is common. So the universe for this one is this. That means the universe is 0 to 1 and union 1 to positive infinity, or you can say this is what? 0 to positive infinity, except what? Excluding what? Excluding 1. We can express like this also. Both are the same. If that's so, we can solve this one. How can we solve this? To solve this one, we express this logarithm function into exponential. That means x squared is equal to what? X plus what? 6. What's what? This means x squared minus x minus 6 is equal to what? 0. Still, this quadratic equation, we'll try to find two numbers whose sum is negative 1 and their product negative 6. What are they? Negative 3 and 2x. Minus, here is 3x, here is plus 2x, minus 6 is equal to what? 0. What's common for the first term? X is common, x minus 3. For the last two terms, we have common is what? 2. Here we have 2x minus what? 3 is equal to 0. Then what? This is x plus 2 times what? Here is x minus 3 is equal to what? That is 0. What the zeros of this? The zeros of this is what? X is equals negative 2, or what? X is equals what? 3. So we have to consider the interval that we have. X is equals negative 2 is not in our universe or in the domain. So the only value that we have is what? X is equal 3 is what? The only solution we have in our domain, since 3 is obtained what? Between 1 to positive infinity. In case of E, we have log of x minus log 3 is equals log of 4 minus log of x plus 4. In this case, we have a difference of what? Logarithm. If that's so, we have to determine the domain of each. Domain of log x is what? X must be greater than 0. And the other one is what? Log of x plus 4 is what? X must be greater than what? Negative 4. What is common? Which implies what? X greater than 0 is common. So the universe or the domain of this is what? 0 to positive infinity. If that's so, we can solve this one. This is the difference of logarithms. If that's so, we can divide logarithms, which is equal to what? Log of x divided by 3 is equal to what? When similar, here we have the difference. Log of what? 4 over what? X plus 4. In both cases, there is no base. No base means what? That is the common logarithm. The base is 10. If that's so, these two logarithms are equal if and if what? The x over 3 is equals 4 over what? X plus 4. This means x over 3. This is true if and only if x over 3 is equals what? 4 over what? X plus 4. Here we have. Now we can crisscross this one. This implies x into x plus 4 is equals what? 3 times 4, that is 12. 12. What? This implies x squared plus 4x minus 12 is equals what? That is 0. We try to find two numbers whose sum is 4 and their product negative 12. The numbers are what? 6 and negative 2. X squared, we can express this as forms plus 6x minus, here is 2x minus what? This is 12 is equal to what? 0. Similarly, as we did before, common for this is what? X plus 6. Common for the last is what? Negative 2 into x plus 6 is equals what? 0. Which implies what? This implies x minus 2 times what? Here is x plus 6 is equals what? This is 0. Then find the value of x. X is equals 2 or what? X is equals negative 6. So which one is the correct answer? Since the universe is what? 0 to positive infinity, the correct answer is what? Our answer is, this implies x is equals what? That is 2. It is obtained in our domain, but x is equal negative 6 is not in the domain. We can consider here is what? 1 plus 1 over x must be what? Which is equals what? X plus 1. X plus 1 what? Over x. What the zeros of this is what? Negative 1 and 0, yes? So you can use sign chart also. Here is 0. When you consider x plus 1, it is 0 at negative 1, at the left it is negative, at the right it is positive. When you consider x, it is 0 at 0, at the left of 0 that is negative, at the right it is positive. So take the equation x plus 1 divided by x. Negative times negative it is positive. Or 0 times this one as well, that is 0 divided by negative, that is 0. Positive divided by negative, it is negative. Positive divided by 0, it is meaningless. And positive times positive is what? Positive divided by positive, it is what? Positive. So it is positive when the domain for this one is what? Negative infinity to negative what? Union what? Union 0 to positive infinity. This is the universe for this one. So the solution must lie on these intervals. If that's so, we can express this as a form of what? Exponent, which is equal to what? 2 to the power of 3 is equal to what? 1 plus 1 over x. What for? This is 8 minus 1 is equal to 1 over x. What does imply? This implies what? 1 over x is equal to 7. What the value of x? X is equal to 1 over 7. The value for this is 1 over 7. Yes, it is obtained in this interval, so it can be a solution for this logarithmic equation. Last problem that we solve here what? 1 plus x. Here what? Here is 3x minus 5. So restrict the domain. That means 1 plus x greater than 0 at the same time, and 3x minus 5 must be greater than 0. But the value for x is greater than negative 1, and that makes both true. X must be what? Greater than 5 over 3. Which one is common for both? The common one is, which implies x greater than 5 over 3 is common, which is equal to what? 5 over 3 open interval. Here is open interval to positive infinity. After that, we can solve this one. Since it is sum of the two, we can take the product since they have the same base, which is equal to what? Log of 2 into 1 plus x in base 2 is, here is minus this, minus of log of 3x minus 5 in base 2, which is equal to what? 3. Again, we have the difference with the same base, so take this one as equation. Here is 2x, that is 2x plus 2 divided by what? Divided by 3x minus 5. We apply the properties in base 2, which is equal to 3. After that, we can express this as form of what? Exponent, which is equal to what? 2x plus 2 over what? This is 3x minus 5 is equal to the power of 3. To the power of 3 means what? 8. Here you have 1. After that, crisscross both and take their product, which is equal to 2x plus 2 is equal to what? 8 times 3 x, that is 24x, minus 5 times 8, that is 40. Now collect similar terms, variable with variable, constant with constant. This means 24x minus what? This is 2x equal to 40 plus what? That is 2. Which is equal to 24x minus 2x is what? That is 22x, which is equal to 42. What the value of x? The value of x is equal to what? X is equal to 42 divided by 22. Here is by 2, here is 21, this is by 2 what? This is 11. So the value for x is what? 21 over 11. It is obtained what? Can you find here? Yes. 21 over 11 is what? Still greater than 5 over 3. If that's so, this is the solution for that logarithmic equation. So we can solve different problems, that is logarithmic equation, using such properties.